Dear listeners, I will speak on galvanometer. Galvanometer is a device used to measure electric currents. It is constructed by suspending a rectangular coil in a radial magnetic field. It is shown in figure 1. The coil is suspended in a space between North Pole and South Pole. The pole faces are cylindrical, so the magnetic field is radial. You see it in figure 3. Magnetic field North Pole, South Pole. Magnetic field is radial. And it is the upper arm of the coil which is suspended vertically. There is a soft cylindrical iron core. Soft cylindrical iron core inside the coil, and the coil can rotate about a vertical axis. The iron core is used to strengthen the magnetic field. The coil is supported and mounted by two springs. One is on the upper part and another is at the lower end. The radial magnetic field B is always parallel to the plane of the coil for all its angular positions. A pointer is joined to the coil and it rotates with the rotation of the coil. I invite you to see the internal structure of a galvanometer. Here is a galvanometer. You see a magnet here. Its pole faces are cylindrical. The suspended coil, rectangular suspended coil you see inside the magnet, and there is a core, soft iron cylindrical core inside the coil, and a pointer is attached to the coil. It rotates with the rotation of the coil. The coil rotates when a current flows through it. The coil is mounted by two springs, a upper spring and a lower spring. When a current flows through the coil, then a couple and thereby a magnetic torque is produced on it. As the coil rotates, the spring opposes it. The amount of the magnetic torque tau equal to NIAB sin theta. Here theta is 90 degree. Therefore, sin 91 n tau equal to NIAB. It deflects the coil, so it is a deflecting torque. When the coil is deflected, the supporting spring is strained. So a restoring torque tau prime is created in the spring, and it is proportional to the deflection. That is, tau prime is proportional to the deflection phi, and it is opposite to the deflection. It is a restoring torque. Therefore, tau prime equal to minus kappa phi. The deflecting torque and the restoring torque are equal and opposite. That is, deflecting torque tau equal to minus tau prime, that is kappa phi. Kappa is equal to tau by phi. Kappa is called the torsional rigidity of the spring. Kappa equal to tau by phi. So kappa can be defined as the amount of the deflecting torque for unit deflection. That is, the amount of deflecting torque needed for unit deflection is called the torsional rigidity of the spring. It is the characteristics of the spring. Now we can write NIAB equal to kappa phi. That is, I equal to kappa by NAB into phi. It is a constant. Therefore, I is proportional to phi. Kappa, NAB, all are known. Thus, we can measure the current by observing the amount of deflection phi of the coil. So, it is an ammeter, but the range of measurement is very much low. Thanks.